In order to help you memorize all these, I want to go through all of the VSEPR geometries, and I want to talk about the general patterns, okay? So first off, we're going to start with linear, and linear is just pretty straightforward, right? It's just a straight line. That's kind of what that means. All right, so if I add another atom, that's going to be trigonal planar, okay? And its best geometry is all in one plane, and the bonds are 120 degrees apart. Now, planar, being in a plane, is a motif that shows up a lot in this naming, okay? So we'll keep a look at that. Now, if I take this out, if I take out a bond and I add a lone pair, okay, now again, we only name the bonds, okay? And we call this, it's no, even though there are three things, it's not in a straight line anymore. It's a bent line. Ha ha ha. So the structure is called bent. All right. Now, it's a little less than 120 degrees. Okay. Don't need to know what it is. I just need you to know that it is less than 120 degrees. Okay. Now, the next thing is tetrahedral. So I'm going to remove the lone pair. I'm going to add. Okay, so there's 4 bonds, tetrahedral. There's 1, 2, 3, 4 sides to this face. Okay, now if I take out an atom and I put in a lone pair, okay, that makes this a 3-sided, very short, fat pyramid. Okay? And again, the existence of the lone pair will push these away, these other bonds away, so the bond angles will be a little less than 109 degrees. Okay? And if I take and I remove another atom and I add another lone pair like this, okay, now this is another bent structure, okay? Now the base of this bent structure is tetrahedral, not base trigonal planar, all right? So these are all things that you kind of have to keep in mind, all right? And this one, I'm just fine with you saying it's much less than 109 degrees, okay? Next, if we go up to 5 things, all right, now, this is a really interesting structure. It's interesting because what we've done is we've basically taken the trigonal planar piece right here, and we've added a top and bottom. And the top and bottom are 90 degrees, or perpendicular, to the plane of the trigonal planar piece. Okay? Now, when I look at this, the way that this structure is named is it's going to use the pyramids. The pyramids show up a lot in these too. All right, so this has a pyramid on top, one side here, and one side here, and then it also has another pyramid on bottom. So you can think of it as kind of 2 pyramids that are stacked top and bottom on each other. Okay, and we call that trigonal bipyramidal because those pyramids are again 3-sided because of the trigonal planar piece. All right, so now I add in a lone pair. Okay, now the lone pair, the positioning of the lone pair is actually kind of important here because if I were to try to take this lone pair and put it in here, what would happen is you'd end up with the lone pair perpendicular to 3 bonds, and that's bad, okay? Because remember, the lone pairs take up more space than the bonded pairs. So you want to have the lone pairs as far away from all the bonded pairs as you can. So in this structure here, instead of being perpendicular to 3 bonded pairs, it's only perpendicular to 2. So this is a better structure. Okay? So now if I take this and Let's see if I can figure out how to... All right, so this structure, oops. Let me get it back to, okay. Take the lone pair out. Okay, this looks like a seesaw, okay? That's the name of the structure. It is an honest-to-goodness seesaw that, you know, maybe one kid sits on this side, the other kid sits on this side, and then they rock back and forth, which I'm having trouble kind of doing with the way that this wants to be manipulated. I could do it this way. Okay, so there's the kids going up and down on the seesaw, yay. All right, so that's seesaw. Now, the important thing to keep in mind with seesaw is that the lone pair is, again, going to repel things. And the lone pair is going to be pushing down on these two bonds. So those bonds are going, those bond angles, these bond angles, are going to be slightly less than 90 degrees. Okay? Now, and that'll push these away a little bit too, so they'll be slightly less than 120 degrees. So again, not interested in knowing the exact values, I just want to know that you know that the lone pair is going to push things away. So less than 90, less than 120. Okay, so if I take out another atom and add another lone pair, okay, now this makes, get rid of the lone pairs, this makes the shape of a T. Hey! Okay? And again, I've added the electrons into what was the trigonal planar piece. Okay? All the electrons in this series go into the trigonal planar piece. Okay? Again, the existence of these lone pairs here is going to push down on everything, push everything away from them. So that's going to make this bond angle slightly less than 90. All right, so now I remove bond, add a lone pair, and I get to, whoa, my goodness, look at that shape. We're back to 180 degrees, okay? And so this shape is, once again, linear. All right. So now the last one is base 6. 2, 3, 4, 5, 6. Okay, so now this looks like it's kind of similar to the tetrahedral, but instead this is an octahedral. It's got 8 faces. Here's one face, here's 2 faces, there's another face, there's 4 faces, and then the same thing on the top, okay? So if you look at this, there's linear, then there's trigonal planar, and then trigonal bipyramid. So these two are kind of related to each other because there's trigonal planar and the trigonal bipyramid. Then there's tetrahedral, and then skip one, and then octahedral. Okay? So maybe that'll help you remember. Now, I'm going to remove a bond, and I'm going to add a lone pair. And it actually doesn't really matter where I put it in because they're all 90 degrees apart. Okay? So now, okay, let me orient this. Okay, now this structure is a pyramid again. It's a 4-sided pyramid. But instead of the trigonal pyramid, where there's 3 sides, this one has a base, oops. This one has a base that's more or less, so there's the top of the pyramid. This one has a base that's a square, okay? So it's called a square pyramid, all right? Now when we add another lone pair, what we're going to do is we're going to remove this one because you want the lone pairs as far apart as possible. Add in a lone pair. Okay. And now this is just a square, okay, square, and it's all in one plane, so square planar. All right, square planar. Now I add another one in, and it doesn't really matter where. Okay. And then I'm going to take out the lone pairs so you can see. This is once again a T-shape. All right? And again, with this T-shape, the bond angles are going to be a little less than 90 degrees. And the last one is once again linear. Okay? So that's running through all of these. I'll run through this again with like the physical models in class, but hopefully this helps you just kind of memorize everything. And it really does. You gotta be able to picture these things in your head. You gotta learn the patterns, and that'll help you memorize this.